Hello everyone. In this video we are going to talk about modular arithmetic. We are going to talk about three different problems and we are going to deep dive in each problem separately. These problems are very common in different math exams and competitions. To do this, we will first review some basic properties for modular arithmetic and then for each case we are going to solve them separately. Before moving forward to talk about the solutions, make sure that you pause the video to think about each problem. Let's start with reviewing some properties of modular arithmetic. First, let's say that the variables that we have here are integers. Given an integer n greater than 1, called modulus, two integers a and b are said to be congruent modulus n if n is a divisor of their differences. Here is an example. We would say 38 and 14 are congruent for modulus 12 because you can write 14 as 12 plus 2 and you can write 38 as 3 times 12 plus 2. So both these numbers are going to have exactly the same values for their remainder if we divide them by 12. With that, let's review some properties. In the most straightforward approach, we can say that each number is congruent to itself for a modulus n. We can also say that if a and b are congruent for modulus n, then b and a are also congruent for modulus n. One additional property is that if a and b are congruent for modulus n, and then b and c are congruent for the same modulus n, then we can say that a and c are also congruent for modulus n. More importantly, if a and b are congruent for modulus n, then we can add an integer like k to both sides. We can also multiply both sides by an integer like k. In another case, if we have a1 and b1 congruent for modulus n, and a2 and b2 congruent for modulus n, we can add them together or we can subtract them from each other. We can also multiply them together. One more important property is that if a and b are congruent for modulus n, then we can use a to the power of k is congruent to b to the power of k for the same modulus n. K is a non-negative integer here. For the last thing, we are going to say if a and b are congruent for modulus n and we have a polynomial like p with just integer coefficients, then p of a is going to be congruent with p of b for the same modulus n. With all these, let's start to talk about the solutions. For the first problem, we are going to find 5 to the power of 22 plus 7 modulus 8. You can also say that we are looking for the remainder of 5 to the power of 22 plus 7 if you divide it by 8. The percent sign that you are seeing here is a common sign used usually in programming languages to represent remainder. Let's talk about the solution now. To solve this, we are going to start with what we have in the equation. We have 7, we have 5 to the power of 22, and we want to find sum of them modulus 8. First, note that 7 is 8 minus 1. So we can say that 7 and minus 1 are congruent for modulus 8. Now let's move forward and talk about 5 to the power of 22. Remember 5 to the power of 2 or 5 squared is actually 25. and 25 is 3 times 8 plus 1. So you can say 5 squared and 1 are congruent for modulus 8. Now we just need to write 5 to the power of 22 in a way that we relate it to 5 to the power of 2. And that's simple. We just use 5 to the power of 22 is equal to 5 to the power of 2 to the power of 11. Instead of just using 5 to the power of 2, we are going to use 1 because 5 to the power of 2 and 1 are congruent for modulus 8. And then we have 1 to the power of 11, which is 1. So at the end, we are going to have 5 to the power of 22 modulus 8 is going to be 1, and 7 to the power of 1 modulus 8 is going to be minus 1. We need to add them together. And if you do so, you're going to find 0 for the final answer. So we can say that the remainder of 5 to the power of 22 plus 7, if you divide it by 8, is going to be 0. We can also say that 5 to the power of 22 plus 7 is going to be congruent with 0 for modulus 8. The other way to talk about it is to say that 8 is the divisor for 5 to the power of 22 plus 8. Now let's move forward with the second problem. For the second problem, it's a little bit more complicated. We have 27 to the power of 24 minus 19 to the power of 18, and we want to find the remainder if you divide it by 10. The other way to look at this is to say what's the rightmost digit for 27 to the power of 24 minus 19 to the power of 18. Let's figure it out. To solve this, we are going to divide it into two sections. The first one is the first term, and the second section we will talk about the second term here. We have 27 to the power of 24. We want to find its remainder if we divide it by 10. Note that 27 can be written as 10 times 2 plus 7. So 27 and 7 are going to be congruent for modulus 10. Remember, we could apply power operator here. So we will use 27 to the power of 24 is congruent with 7 to the power of 24 for modulus 10. Now we want to simplify it further. Remember, 7 squared is going to be 49, which is very nice for modulus 10 because we know we can write 49 as 50 minus 1, and 50 divided by 10 is going to be 0. So at the end, we can say 7 squared and minus 1 are congruent for modulus 10. So 7 to the power of 2 to the power of 12 is going to be congruent with minus 1 to the power of 12. Since 12 is an even number, the answer is going to be 1. So at the end, 27 to the power of 24 and 1 are congruent for modulus 10. Now let's move on and talk about the second term, which is 19 to the power of 18. It is a little bit simpler. 19 is 10 times 2 minus 1. So 19 to the power of 18 is going to be congruent with minus 1 to the power of 18, which is 1. So both the first term and the second term are congruent with 1 for modulus 10. And if you subtract them, you're going to have 0. So we can say that the rightmost digit for 27 to the power of 24 minus 19 to the power of 18 is going to be 0. We can also say that 10 is the divisor for 27 to the power of 24 minus 19 to the power of 18. Now let's move to the third problem. Here we have 13 to the power of n plus 6. We want to find its remainder if you divide it by 7, and we don't know the value that we have for n. To talk about the solution, let's start with 6. We know 6 and minus 1 are congruent for modulus 7 because 6 is 7 minus 1. Interestingly, 13 and minus 1 are also congruent for modulus 7 because 13 is 2 times 7 minus 1. So let's use 13 to the power of n, and then we will have 13 to the power of n is congruent with minus 1 to the power of n for modulus 7. But we don't know the value that we have for n. However, we can put some conditions here. If n is even, minus 1 to the power of n is going to be 1. If n is odd, minus 1 to the power of n is going to be minus 1. So we have two cases. For even, the whole answer that we have for 13 to the power of n plus 6 is going to be 0 because we have 1 for the first term and negative 1 for the second term. On the other hand, if n is odd, then the whole answer is going to be minus 1 plus minus 1 or minus 2 for modulus 7, which is basically 5 for modulus 7. Thanks for watching the video. If you would like to see more puzzles and math involved activities, please subscribe to the channel.